Hi everyone, I hope you're okay. This is the ninth video, guys, which simply means I'm doing question 9. Please note that, guys, there are 8 videos being uploaded before this one, whereby I'm tackling the 2023 mathematics paper 2, which was written in the month of November in the province of KwaZulu-Natal. Each question each question has its own video. It simply means that there's a full playlist, guys. You can just click the link on the description below. It will direct you to the playlist with the full memorandum. You can download the question paper, answer the questions with me. If there are things you're not sure about, please do ask on the comment section. I will definitely come and assist you. And please don't forget to share the video to your peers. Maybe help one another while preparing for your final examination. Yeah, let's work. Okay, we are told that ABCD is a parallelogram and BH bisects angle ABC. So this angle and this one are equal. Okay, and then HC bisects angle BCD. Also this one is equal to that one. Okay, and then we are told that angle ABC is 60 degrees. Angle ABC is 60 degrees. So that means I simply have 30 degrees and 30 degrees over here. Okay, and then angle F is equal to 120. Okay, that's 120 degrees. Okay, BH is parallel to HG. Where's BH? BH is parallel to HG. Okay, that's indicated. And then BG is parallel to HC. That's indicated as well. AD is produced such that AB is equal to DE. AB, okay, that's indicated. BC is produced to F. Okay, the first thing they want us to do is to show that angle C1 is equal to 60 degrees. Okay, how can we do that? Remember that we were told that ABCD is a parallelogram, right? This particular shape over here, this one is a parallelogram. So since it is a parallelogram, it simply means that we have co-interior angles in here. Are we together? So it simply means that angle ABC plus angle BCD, they add up to 180 degrees. Why? Because these are two angles between two parallel lines. They are co-interior angles, and they are co-interior because AB is parallel to CD. Because AB is parallel to CD. Why do I conclude that AB and CD are parallel? Because ABCD is a parallelogram. I know for a fact that in parallelograms, opposite sides are equal and parallel to one another. Okay, angle ABC was given to me as 60 degrees. I don't know angle BCD, but now I know that BCD will be equal to 120 degrees. Are you together? But remember that BCD, we were told that line HC bisects angle BCD. So if BCD is 120, I know that C1 will be half of 120. Angle C1 will be half of 120 degrees, and then C1 will be 60 degrees. Why? Because HC bisects angle BCD. So now I've proven that angle C1 is equal to 60 degrees. Okay, now I'm supposed to prove that BGCH is a rectangle. BGCH is a rectangle. Okay, for me to have a rectangle is a special case of a parallelogram, right? If I can just show that the opposite sides are parallel and one of the angles is equal to 90, I can therefore conclude that I have a rectangle. Okay, how can I do that? Remember that these two lines are parallel, right? Line BF and GC, they are parallel. So that simply means that I have alternating angles in here. So that means angle C4 is 90 degrees. Are we together? C4 is 90 degrees. Is equal to 90 degrees. Mangam. C4 is 30. Angle C4 is equal to angle B2, and both of them are 30 degrees. I'm saying they're equal because they are alternating angles. And they are alternating because BH, is parallel to CG. All right, together. If I can show that angle C1 plus C4 is 90 degrees, I can therefore conclude that I have a rectangle there. Okay, angle C1 plus angle C4 will be equal to, remember that we've proven C1 to be 60 degrees. That's 60 plus 30, which is equal to 90. So therefore, BGCH is a rectangle. All right, together. Why? Because opposite sides of BGCH are parallel, and I've just shown that one of the angles is equal to 90 degrees. That means all of them are 90 degrees. All right, together. Okay, now I'm supposed to show that DC is parallel to EF. Where is DC? Okay, that's DC over there. DC is parallel to EF. Okay, remember that I found this angle over here to be equal to 120 degrees. I did that in 9.1. Yeah? Okay, I found angle BDC to be 120 degrees. Or BCD. What's angle? Yeah, it's BCD. This was proven in 9.1. And I was told that angle F is also 120 degrees. This was given in the opening statement, that angle F is 120 degrees. So this thing simply means that if these two angles are equal, that means these two lines are parallel. Why? Because you have corresponding angles. So therefore, DC will be parallel to EF. Reason, because the corresponding angles are equal. And those corresponding angles are angle BCD being equal to angle F, and both of them are 120 degrees. That's how you show that two angles are parallel. Okay, now I'm supposed to show that DC and DE are equal. Where is DC? DC and DE are equal. Okay, remember that, guys. I was told that ABCD is a parallelogram, right? Remember that the properties of a parallelogram are that opposite angles has to be parallel and equal. So if that's 30 centimeters, that means DC is also 30 centimeters. Are we together? Line DC will be equal to line AB, and both of them are 30 centimeters. Why are they equal? Because they are opposite sides of a parallelogram. Opposite sides of a parallelogram are equal, right? And DE was given to us. So therefore, DC is equal to DE, which is 30 centimeters. Okay, now I'm going to show that DCFE is a rhombus. DCFE is a rhombus is a special type of a parallelogram. Ne? The opposite sides of that parallelogram must be parallel, and the adjacent sides must be equal. Are we together? So this side and this one, all of the sides must be equal to 30 centimeters. Are we together? Since F is an extension of BC and E is an extension of AD, right? Remember that BC was parallel to AD. This will simply mean that DE will also be parallel to CF. Why? Because DE and CF are extension of two parallel lines. So that's why I'm going to say DC is parallel to FE. Are you together? And then we did show that no, it's not DC. That's DE and CF. Okay. DE is parallel to CF, ne? Why? Because they are extension of two parallel lines. Are you together? But initially in 9.3, we've just shown that DC and EF are parallel. DC is parallel to EF. Are you together? This was proven in 9.3. And also DC being equal to DE, which was proven in 9.4. Now we have a situation whereby opposite sides are parallel and the adjacent sides are equal. So therefore, DCFE is a rhombus. Is a rhombus, ne? Why? Because the opposite sides are parallel and all the sides and all the adjacent sides are equal. So that's why we have a rhombus. Thank you for your time, guys. Just stay tuned and wait for more videos. Thank you.